Hello, assalamu alaikum everybody. Am I audible? I apologize, I just got a bit late. I had a bit of a work to do, so apologies for that, but we got a bit late. So, and also I was setting up the stream, so a bit of time went on to that. So, how is everybody doing? Am I audible? First and foremost, let me know, am I audible or not? Let me open it up on my phone because this is the first time I'm trying to stream onto my channel. So I just want to have a look at how it goes. Hello. Guys, am I audible clearly? If anybody could kindly confirm in the chat box. Perfect. Alright, assalamu alaikum everybody. Background noise too much? There shouldn't be background noise though, but let me have a look at it. So, filters, and let me try to, just a minute, let me set this. Alright, I hope the background noise problem is much better right now. Am I audible now? And is the background noise anywhere somewhat better? Okay, let me change one thing. I guess the delay was of 45 seconds. That's a bit too much. Let me just change it to 30 seconds so that you guys can talk to me more often. Walaikum assalam. So, is the voice better now? Alright. And I hope you guys can also hear me now clearly. Okay, let's start off. By the way, we won't be doing questions today. Today we will just be basically learning the concepts, which is basically the entire chapter number 3. We're going to discuss that in great detail. We're going to cover up everything which is there in the syllabus. We're going to go through the entire course in detail, and inshallah from tomorrow onwards we will be basically then jumping into doing some topical questions. Now what I want from every one of you out there is to basically not waste their time by basically, no, we do not have a class on Zoom today, it's just on YouTube. So yeah, the only thing which I want from every one of you out here is that please only ask the questions which are relevant so that you don't waste the potential of asking a question. Okay, so I'm just going to send one message in the group that we have started off, and so for anybody who might not join in, they can also join us. So join in folks, and here's the link. So let's start off. Bismillahirrahmanirrahim. Let me start screen sharing and then we can start off with it. By the way, you can also share the link with your friends. They can also join in. The recording most probably would be available afterwards too, inshallah. So anybody who might want to have a look at it later on, that's also perfectly fine. But today we will be inshallah discussing the entire chapter 3. Now originally my plan was doing the entire course, but unfortunately doing that was a bit challenging, to be honest. And so what we decided was that rather than doing everything, it's better if we go with one of the topics, and rather than, what do we call it, let's start off. Yeah, so rather than covering up the entire course, what we can do is we can basically cover up one topic which everybody feels a lot of challenge in, and after that from tomorrow onwards we can basically do topical practice. So we're going to do a lot of topic wise questions one by one. We're going to do everything in great detail, and this will basically allow us to understand the topic in great detail, inshallah. Say yes, we will be inshallah completing the whole chapter today. That's the goal. However, let's see how good do we go, but yep. So let me just go. We did a lot of papers in our past paper session, so let me just go to the topic where we doing topic number 3. By the way, this is some great number of questions we solved, but yeah, let's go to chapter number 3. Let's start off with this. Bismillahirrahmanirrahim. Alright, so when we talk about chapter number 3, chapter number 3 basically discusses the concept of hardware. And when we say hardware, a lot of people usually just think that we are talking about input-output devices, or we are talking about something which is not that much relevant. Okay, so if my camera is a bit lagging, you can sort of ignore that. If the screen lags, let me know. Okay, how long will the stream be? I don't know. Let's see how much time it takes, but I feel like it has to go for at least 2 hours, if not more. So expectedly we're gonna go till 12:30. Alright, isn't perfect. That's great. So let's start off with the concept for today then, inshallah. Walaikum assalam, walaikum assalam. We're gonna discuss everything, okay? All these working and stuff questions, everything will be discussed in great detail. So, chapter number 3, hardware. So remember, when we start off with the topic of hardware, there are basically three major parts about what's there in the hardware topic. So you start off with the discussion of your computer architecture. You discuss the computer architecture as to how a computer behaves, what are the components within the computers, how they basically work and everything, okay? And then after that, you go on to discussing the input output devices, which we also refer to as IO devices. And once we are done with discussing the IO devices, the last part of your syllabus for chapter number 3 basically discusses the topic of memory plus network interface card, of how you basically get connected to the internet, okay? So we're gonna start off and let's see how it goes. Send the link. So yep. All right, so let's imagine firstly we need to understand what a CPU is. So for instance, one of you out there gets an A star in their computer science exam, inshallah, and then they're like, okay, I need to get myself a new computer. So what they do is they basically go to their parents and they're like, okay, I need to grab a new gaming PC. And when they go to that computer guy, the person who basically sells and makes those computers, the person is like, okay buddy, what processor do you want? So this question about what processor you basically want in your computer is something which is the backbone of the entire chapter number 3, okay? So when we talk about the word processor, the processors such as Core i9, Core i7, Core i5, Core i3, the Ryzen series, the MacBook M1, M2, M3, M4 series, all of these are basically what we call as a CPU or a processor. So I will not be doing I won't be going into a lot of details over the basic stuff. I'm just going to go through and skim through that so that we can understand the main important part which is going to be tested in your exam. So remember, whenever we talk about the word CPU, the CPU is basically the brain of a computer, okay? So the full form of CPU is the central processing unit, and its whole responsibility is to basically process and execute the instruction and data in a specific computer application. So it's that brain of your computer which allows you to make decisions, which allows you to do some specific things, which allows you to basically take action whenever you detect some problem, okay? And what your CPU generally consists of is that your CPU first and foremost includes something we call as a control unit. Okay, we're going to see what control unit is. It is having something we call as an arithmetic logic unit, or ALU as a short form, and it has something we call as registers and buses. So these three parts basically make up what we call as a CPU, and we're going to discuss all of these three things in great detail. Now, starting off, the very first thing which we're going to be studying when we talk about the components of a CPU is the arithmetic and logic unit, okay? So ALU is basically the mathematical geek in your computer brain. What it does is that whenever your computer wants to do some mathematical calculation, definitely it's a computer, right? And computer always has to do mathematical calculations. Maybe even if I'm copying some data from one folder to another, the data which is being transmitted, it follows the mathematical rules. And any calculation which is being stored in between, or any calculation that is being conducted at that time, it is being done by the arithmetic and logic unit. So you can say that it's the mathematical geek in my computer brain. Whenever I want to make some sort of mathematical calculation, the CPU is like, bro, let me call arithmetic and logic unit so that they can solve that for me. So if ever a question comes up in your exam, do know that arithmetic and logic unit, basically it's that part which performs the mathematical and logical calculations. Now here 2 points are very important, okay? One is, what do we mean by when we say mathematical, and what do we mean by when we say logical? People generally do not understand the difference between them. Remember, when we talk about the arithmetic part, the arithmetic is basically referring to the mathematical operators. For instance, plus, minus, divide, multiply, okay? Whereas logical refers to your operators such as and, or, not, nor. So if I, let's say, want to make a condition that if age is greater than 18 and age is less than 20, so this greater than sign is basically something which comes under arithmetic part, okay, where it's like a mathematical operator, whereas this and is something which comes under the logical part. And altogether, whenever you have an expression, whenever you have some sort of command, and your computer gathers the arithmetic and the logical part into one single place, we call that to be as the ALU, or the arithmetic and logic unit. So we're going to further explore this in paper number 2 inshallah, but I hope you all are well aware about this because this is the backbone of what we studied in chapter number 10 as logic gates. We're going to do inshallah enough amount of 15 markers too, so for anybody having the constraint and they think that okay we are cooked with paper number 2, you aren't cooked. We're going to do 4 to 5 papers together inshallah. You will be able to ace that paper on the 20th inshallah. Moving on, remember that the part of your CPU which is basically responsible for carrying out all the arithmetic and logical expression is basically known as the ALU. So next time a question asks you for a definition, please memorize these key definitions rather than writing something vague. A lot of you would be like, we know it, we know this, we know that, but just know that what an ALU consists of is this. It's basically a part of the CPU which carries out all the logical and arithmetic expression, and if ever in exam it asks you, you need to write this definition. Don't write some sort of vague statement, because if you write vague statements in paper number 1, you won't be getting marks. Moving on, the second component of your CPU is basically known as the control unit. So what I call control unit in simple word is the CPU's CEO or the president. For instance, like if I own a company and the company has a president or a CEO, we know that the CEO is the most superior position, right? It's that position where people can make decisions. It's that position which is going to order people to do this. It's going to be telling people that, okay, buddy, you need to do that, you need to stop at this point. So this thing, when it's applied to the world of computers, where they want to execute instructions in a way where it wants to order a computer to, okay, do this work, don't do that, stop this, stop that, that is basically known as a control unit. Don't worry guys, these notes are openly available on my website. You can just open up my website, go to the chapter number 3 notes, and you can find all of them. So if anybody wants to have a look at the definitions and all, they can later on review them again and you will be good to go. Okay, for now just understand the concept. Now currently it's the game of concepts. So when I talk about control unit to be as the CEO or president, what I mean from this is that control unit is basically that part of your CPU which basically takes an instruction from the memory. Okay, it takes an instruction from the memory, and then it's like, okay bro, now I need you to be processed. So it's going to send signals throughout the computer, timing signals and all sort of synchronization signals to ensure that the correct way of solving or processing that specific instruction is executed. Okay, so what's going to happen is that if I, let's say, want to do 2 plus 2, this 2 plus 2 instruction is going to go to my control unit, and my control unit would be like, okay, I know this thing needs to be done by, let's say, the ALU. So it's going to send a signal to the ALU to start executing it, and then it's going to just overlook everything, ensuring that everything is being done in the right way. And likewise, of course, if I'm, let's say, a leader of a company and I'm the CEO, and some company comes to me and gives me like a project, like a client gives me a project of 1 month, you know that it's the task of the CEO to ensure that the work is being done in 1 month, right? Or the leader's work to ensure that it's being done in 1 month. So likewise, your control unit also basically has this one thing where it ensures that everything is done in the perfect right manner. Like there isn't a possible way, right, that if I have to basically execute this answer, which is 2 plus 2 equals to 4, is there any way possible that I first store the answer before even calculating it in some memory position and then later on I add the values? No, right? You always have to basically add the values first, then you're going to get an answer. You're going to take this answer and you're going to store that answer somewhere, right? That's how we generally execute it. So now what your control unit does is it ensures this synchronization, or this basically steps to ensure that there are no delays whenever you want to send data and instruction through the computer. So next time a question comes up in exam where they ask you, how does your computer ensure synchronization and ensures that your data and instructions are executed without any delays, know that all this credit goes to our beloved control unit, which has a short form of CU. A lot of the time students reach out to me and they ask, sir, in exam, should we write the full form like control unit, or should we even write the mnemonics like CU? My personal advice would be to go with the longer form, the full form like control unit. However, in marking schemes for words such as like MAR, if you open up the marking scheme always says stuff like MAR followed by memory address register, which basically is a clear indicator that yeah, even if you write MAR as a short form, you would be good to go. However, my recommendation would still be to go with this. Okay, it's better to write it long, the full form. You don't have to waste a lot of time. It's like you have like a lot of time, so it would be very much good to go, inshallah. Okay, moving on. Just know that when we talk about control unit ensuring synchronization, this synchronization is basically something which is being done by the production of timing signals, and this timing signals will be further created by what we call as the clock speed, and the clock basically the clock speed then further reconnects within control unit, but we're going to discuss that later on. Okay, so for anybody having the question that, sir, where did clock speed go in this whole discussion, know that clock speed is going to come afterwards. So this timing signal which is being created, this ensures that if one thing needs to be done in 2 seconds and the other task needs to be done in 2.1 second, then your computer ensures that yes, one stuff is done in 2 seconds, whereas the next one is done in 2.1 second. So this basically allows it to have a synchronization of everything, allowing that the whole data moves in the right perfect way. Perfect. So now we have understood that we basically have the control unit for the purpose of creating timing signals, and these timing signals are only used for ensuring that my data is fully synchronized. And when I say the word synchronization, if anybody does not know the definition of it, synchronization basically means that everything is being done in the right order, which basically means that everything is being done in the right way, in the right time, and in the right order. Perfect. Is this clear, everybody? Just know that control unit is that part of your CPU which ensures that everything is done in the right way and in the right manner, ensuring that nothing goes out of order. Okay. Alright, for anybody who might want to understand the whole concept in a further great detail, you can also watch my chapter number 3 playlist. It's uploaded on my YouTube channel. Go there, and if there is any specific concept which is not clear, you can watch the relevant video for that. We have like one hour video explaining all of these concepts about what's control unit, what's ALU. So if you need more help with that, you can ask and watch those. Okay, let's move on. Timing signals would be discussed inshallah afterwards too, so don't worry. Okay, we're going to discuss timing signals even ahead. Alright, let's move on. So what's RAM? A lot of the times whenever we want to create something, we always, whenever we want to play some game, we want to do something, we always say that there is something with the name of RAM. A RAM stands for random access memory. And basically what a RAM does is that it stores the data of all the instructions which are currently being executed. So generally, if I have to explain this specific term, which a lot of students don't get, is that let's say you have a computer, right? And in your computer you have something known as a hard disk, right? We all have hard disk or SSDs in our computer. We do, right? And now what happens is that in your SSD you have installed Red Dead Redemption 2. Now your CPU wants, let's say you want to play this game Red Dead Redemption 2. If you want to play Red Dead Redemption 2, this means that this data which is present in your hard drive, this basically needs to be executed by the CPU. So if anything needs to be executed by the CPU, how will that be carried out? So for that, generally what we do is that whatever part of the data I need to execute at this point, I grab that data and I bring that into my CPU. Or in simple words, it's similar to saying that what we do is, if I, let's say, want to study a specific subject, I don't bring up all the books, right? I'm like, okay, if I want to study CS, I bring up all the books of computer science. I do not bring the books of physics, chemistry, economics, right? So similarly, whatever I want to execute, that part is basically taken into CPU. But now there is a problem. The problem is that if I want to directly take the data from my hard disk into CPU, your hard disk is a very slow person, okay? They don't have the power to be fast. They are like very dumb. They are like very slow, and getting data all the way from the RDR2 basically means that the data will be taken out in a very, very large time. So what computer scientists did was that computer scientists basically created another hardware piece which was known as RAM. But the best part of RAM is that RAM allows you to have a very fast communication. So in simple words, the road between RAM and CPU is like that of a motorway, whereas the road between your hard disk and CPU, that's like your GT road, which is literally very slow due to a lot of traffic. Okay, so this RAM, what it does is that whatever I want to execute, by executing I means that whatever I want to process. Okay, so let's say I want to play some game, so when I'm playing that game, this basically means I'm executing the game, I'm processing the files of the game and everything like that. So what this RAM does is that whatever I want to execute at this point, I grab that specific chunk of data which I need to execute from the memory, whether it's the hard disk, whether it's my SSD, whatever. Okay, I grab that one piece from here and I put that into my RAM. And now because RAM is something which can very quickly communicate with the CPU, which can very quickly solve all the problems, it can then directly communicate with the CPU and then process whatever instruction I was trying to execute. So whether that was playing game, whether that was opening Google Chrome, whether that was loading a video on YouTube, whether that was you writing a message and sending it in the chat box or whatsoever. So what happens is that next time you are asked about a RAM and you talk about the fact that the RAM stores the data of all the instruction, this basically means that it takes the data from the hard disk and it puts that data into RAM, and then RAM basically communicates with your CPU to execute it. Another point here to note is that in one of the marking schemes, you will also see that there's a question which asks you about IAS, which has this full form of immediate access store. So a lot of you would be like, sir, what is IAS? I'm not sure about IAS. So remember, IAS, which is known as immediate access store, this is basically nothing else but your, another name for basically RAM. So it's just a mini different name. So ever if in exam they ask you about IAS, you should be very much clear with the fact that we are talking about RAM, but it's just a different name to it. This is something a lot of people again do not know, but you should be clear with this and you would be then good to go. Moving on, I will not be taking a lot of questions because the whole course content is very much in great detail. However, I want you guys to know one thing. If any question goes unseen, if you don't get a question answered by me, what you should do is list down that question. I'm going to open up the community group after the chat and I want you to send all the questions there, and then everybody can help each other. Moving on, point number 2 would be that for anybody who is asking about the practice part, from tomorrow onwards, so from the 9th all the way till the 12th, or no, perhaps till the 13th, inshallah, we're going to have classes for topical practice. So we're going to do topic wise practice of all the contents, or everything from chapter number 1 all the way to chapter number 6, and then inshallah from the 14th all the way to 17th, 4 days we're going to do paper number 2 practice, and inshallah this would be more than enough to ensure that you guys are good to go. Okay, so just know that IAS, next time you ever see IAS or intermediate access store, this basically means we are talking about RAM. And what's RAM? It's basically the data from the hard disk which is being stored in a specific component which my CPU needs at this point for the purpose of executing it. So IAS and RAM are 100% same. And also at the same time, one other part, sometimes RAM is also referred to as the backing store. Okay, so these are basically 3 identical words. Okay, so that if you see ever in exam the word of backing store, or you hear the word of IAS, or you hear the word of RAM, do know that we are basically talking about the exact same thing. There are no differences between them. Alright, let's move on. So what is RAM? Just know one thing, perhaps we're going to discuss this later on, so for now we're going to leave it. Okay, we're going to discuss this later on inshallah when we are discussing RAMs again. But now we're going to come to the topic of registers. So you would have definitely seen when doing chapter number 1 question where it says it's an 8-bit register, it's a 16-bit register, it's this, it's that. What is a register? Have you ever wondered? So a register is basically a memory slot, a slot which stores a specific value. Okay, so like if I want to store a value of a calculation somewhere, where will I be storing it and how will I be storing it? So like I know that there is something known as a hard disk, which is hardware like this, but how does it store my game files? How does it store all these notes, or how does it store all these applications? So what happens is that whenever you have a hard disk, your computer basically creates multiple registers inside them. Okay, so you have multiple registers within a hard disk, which what happens is that when you create that register, it's going to divide that into smaller chunks where the values 0 and 1 could be stored. Now we all know that the computer always processes itself using binary. So when you have to store the values of binary somewhere, and let's say I want to make some shelves so that they could be placed in those specific columns and rows, those specific rows which are created to store the data about specific thing, that is known as a register. And a register basically stores a value, but remember that every register has a different purpose, because in our syllabus there are 2 types of registers. One is known as the general one and the other one is known as the special purpose one. Now in our syllabus for Igcse or O-level computer science, we are only required to learn a few special purpose registers. So if anybody tells you that, okay bro, have you memorized those general registers, you don't have to think about them. Okay, you don't have to think about them. So what are those special purpose registers? Acha guys, I'm not outdated by the way. Okay, this is your syllabus. If you might want to ask me, I have a NVMe hard disk, SSD by the way installed, and I don't know, maybe I have 16 GB DDR5 RAM installed, and what else? But I have like a very modern sort of gear, so I'm not that outdated. Well, if you want to get a bit outdated in that regards, the problem would be the examiner is going to cook you on result day, so it's better to not get too modern but also revise what's there in the syllabus. So now let's have a look at the special purpose registers. So I'm gonna, okay, what's the name of my website? So let me just send let me even pin it up so for everybody who might have this question. So that's my website, and I'm gonna pin it too. So pin message, okay? So you guys can open up my website. It has all my notes, it has all my resources. You might want to join your community groups and all that stuff, so you can find everything out there. Okay, easy scene. Moving on, now what are those special purpose registers in our syllabus? So the first special purpose register in our syllabus is known as the current instruction register. Okay, current instruction register. So what a current instruction register does is that it stores the current instruction that is being decoded and executed. So now you might be saying, sir, then what's the difference between CIR and RAM? Because like literally 5 minutes ago you were saying that RAM stores the data which is currently being executed. So what's the difference? Now remember, if you ever open up the task manager on your computer, you're gonna see that multiple applications would be opened up. So like for instance, currently I have opened up Google Chrome, I have opened up my notes taking app, I have opened up my WhatsApp, I have, what else do I have open? So I have my streaming software OBS opened up. So I have 1, 2, 3 and 4 items open at once. Okay, 4 items have been opened at once. Now know that all 4 of those items, because they are opened and my computer is processing them somehow, it's not like they are turned off, they are working in the background. Anything which is being executed, even though I might not be directly working on it, but it has been turned down in the background, the data of that is being stored in my RAM. But right now, if I focus upon those 4 apps, out of the 4 apps, I'm currently working where? I'm working on my notes taking app. So this notes taking app is where my currently CPU's whole power is going, right? Where my whole power is currently going. So the data which basically is regarding the notes app, that is then stored in my CIR. So the way it happens is that we take everything which is in the RAM, we bring it in the hard disk which we want to execute, we bring that into RAM. Once we bring all of that into RAM, whatever I'm currently doing, because definitely I at one time cannot do all 4 things, right? There has to be a specific 1 or 2 things. So what I'm currently going to be doing, I'm going to grab that one thing and I'm going to put that in my CIR. And now my CPU is basically going to be talking to the CIR. So it's sort of an advanced version where the data basically comes from the hard disk into RAM, and then whatever in RAM is currently being executed among all the multiple applications that might be turned on, that part is basically brought into CIR, and then my CIR and CPU basically communicates with each other. They're like, oh buddy, what's up, how do I need to solve it, and boom, congratulations, you have completed this mission. So that's the whole purpose of CIR. So next time a question asks you about what CIR is or what current instruction register is, just know that it stores the current instruction that is being decoded and executed. Moving on, the second special purpose register in our syllabus is known as the accumulator. So previously we saw that there is a part of CPU. So your CPU is made in a way where this whole thing is like a CPU, and in this whole big CPU we have basically the let me draw it. Okay, let me draw it. So we have the CPU. Where did the CPU part go so that I can make it there? So yeah, so the way it's being carried out is we have a whole CPU, okay, something like this, and in this CPU we have one part known as control unit, the other part known as the ALU, and of course multiple registers, okay, registers. And then of course all these registers are basically interconnected with each other using stuff known as buses, which in simple words are basically my wires, okay, they are my wires. We're going to discuss the types of these wires, but it's going to be perfect. Is it lagging, guys? Is it lagging? It shouldn't be lagging though, but if anybody could kindly confirm. Let me see. It shouldn't be lagging though. Okay, so it's not. Perfect. Okay, okay. Okay, it's not. Good, good, good. Yeah, you can ignore the camera part if the main screen does not lag. That is what matters. Okay, okay. All right, perfect. Let's move on. So we know that control unit, ALU, and register. These are not my special purpose. What do we call it? Registers. The stuff which are used within the control unit and within the ALU, they are my registers. So now this CIR which we just studied, that basically comes within the CU. Okay, so CIR is basically a register which comes within the control unit. And likewise, the second register which we are just going to be studying, that with the name of accumulator, that comes under ALU. So we just studied that ALU, or the arithmetic logic unit, it's basically the mathematical brain, right? But you tell me one thing, if I want to do some mathematical calculation, like let's say I want to do this calculation where I want to do 2 raised to power 3 plus 5. So I know 2 raised to power 3 is basically 8, and 8 plus 5 is 13. But the way my computer executes it or processes this statement is that it's going to first and foremost solve this. So it's going to convert that 2 raised to power 3 into 8 first, and then it's going to store the 5 separately. Then later on it's going to add the two values so that we can get the final answer to be as 13. Okay, so now the point here to note is that when I do something like 2 raised to power 3, my computer got the answer to as 8. Is this answer 8 stored somewhere? Because my computer cannot memorize everything, right? It needs to store the value somewhere. But I need this value just temporarily, right? I just want to temporarily store that, okay, this was 8, so that when I can add 5 into it and I get my final answer as 13, I will be storing this 13 somewhere in the memory. I don't want to store this 8. But if I have a mathematical calculation where I might want to store something temporarily, how will I do that? So if whenever I want to store something temporarily, and I have that calculation in regards to some mathematical operation, remember that it's basically my accumulator, which is a special purpose register that stores the values temporarily. So it's like an interim it's basically a register which stores the interim calculations for your ALU. So next time your computer does something like 2 plus 5 plus 8 plus 10, if it gets this answer first, this 7 is stored temporarily in a register known as accumulator, and then once I also calculate this 18 will be then added into the value which is basically in my accumulator, so that I get my final answer. And that is how you basically get your accumulator's value. So Ayandar, my internet is working perfectly fine. I have the stream opened up on a different device just on my left hand side, so maybe the problem is at your end maybe, but yeah, I can see the stream, it's working fine though. Okay, so the accumulator, now you all are aware that the accumulator is basically something which stores the temporarily result. So if I do some calculation and there is some result which I want to store temporarily in a specific place, that place is what we call as an accumulator. Moving on, the third type of basically a register which we have in our syllabus, that's known as program counter. So what's a program counter? This is one of the most commonly asked question. What's PC? What's program counter? So you should know that program, it should open though. Let me recheck. It's perfectly working. So a program counter or PC is basically that specific register which stores the address of where the next instruction could be found. In simple words, let's say I say that I want to for instance, do some task where I want to interview people. Okay, I want to interview people. So that list which tells me that, okay, the next person which you need to interview, it's XYZ. That task which the list performs, it's the same as that of a program counter. So your program counter is a register which basically has the address of where and what the next instruction should be. So like if I have played basically Fortnite, but right now I would be like, okay, no, I want to play, let's say, RDR2, Red Dead Redemption 2. So the next thing which I, let's say, opened up RDR2, or like you would have also seen that sometimes you open up an application, you open up a game, you open up a browser, and it starts to get load. It's loading. It does not open up immediately, right? It loads up. So if it's loading, why is there that delay inside it? Have you ever wondered? It's because your CPU is waiting for it to be processed. You are in the waiting line, and while you are in the waiting line, this basically part, what do we call it? This basically part where while you are waiting, but where your address is being stored, that okay, once this thing has been done, the next part which needs to be done, that is basically going to be, oh, easy scene, Ayan, easy scene. So Just give me a minute, guys. Easy scene. Oh, by the way, a few students did not even know that the stream was live. Crazy. A student just messaged to me, sir, आप कब तक आएंगे? Guys, stream started some 30 minutes ago. Lol. Never mind. Yeah. Okay, crazy. All right. So let's move on. So now what we understood is that whenever your computer wants to do multiple things and we have a waiting line being formed the next task which needs to be executed, your CPU needs to know its address. Your CPU needs to know, okay bro, where in memory do I need to go and what files do I need to bring up for it to be loaded. So that address where that could be found is stored within my program counter. And finally, we have our favorite register with the name of memory address register. So for instance, the way it works is that let's say I have my program counter. My program counter basically stores the address of the next instruction. Okay, so now my CPU, when it tells it that okay, I'm free bro, bring up the next data, my program counter sends the address to MAR. Your MAR is basically like your taxi driver. Okay, it's your InDrive, it's your Kareem, it's your Uber. It's gonna take you in the memory, it's gonna take you into the hard disk, it's gonna take you to the SSD, and up there it's gonna take you to the data file. But then the thing is, MAR cannot carry the data with itself. So we also bring up one other car with ourselves with the name of MDR. So that any data which we need to copy, we bring that data into MDR. And then again, my driver MAR, it takes me back to the CPU. And inside CPU, I now take this data and bring it into my CIR for it to be executed. And once this has been done, I would be like, okay, I've completed one task. And now my CPU would be like, okay, bro, bring up the next data. And then the whole cycle is being repeated. This cycle is known as fetch execute cycle. We're going to further re-look onto it again, but we just started off. Okay, it's easy seen, the recording would be available, we haven't covered much, but yeah. So this MAR, what it does is it basically stores the address of the memory location which is currently being read from or written to. That's a definition you should memorize. So wherever I'm taking my computer to, so like in the memory, if I want to find some data or something like that, and I want to find a data at a specific address, the driver which is going to take me to that point, it's known as the memory address register. And your memory address register basically does two functions. It either reads the data or it writes the data. By writing the data or by reading the data, what we mean is that whenever my computer says that okay bro, MAR, read the data at the address 011000101. So what's going to happen is your computer is basically going to go to this address. It's going to go to this address and it's basically going to fetch the data. By fetching the data, I mean it's going to grab the data at that point and it's going to bring the data. And likewise, sometimes we also have to do something like, okay, I did this calculation like 2 plus 2 equals to 4. Now I want to store this 4 in a memory, right? In the memory, let's say I want to store this, or like sometimes you are working on an essay and you save that essay. So now when you want to save that essay, it needs to be stored somewhere in the memory, right? So how will it be stored in the memory? Again, MAR is being used likewise there too. So what your MAR does is it executes the write function at that point, where whatever the data you have created, that data is basically written to that specific address location. So if I say that you need to write 2 to the address location 0101001, so your computer is basically going to go to this address location and then it's going to store the value 2 as the data value there. So it's basically like, okay, I went to house number 011010 and I dropped this box of present there. So that's how your read and write function works. This has been very rarely tested, but you should generally know what the read function does and what the write function does. Okay, moving on, just know that we then have something with the name of MDR, which just the way I said that whenever you might want to go from one part to another and we now want to store the data which has just been read at a specific address, like for example, I go to a house, so taking me to the house is something done by the MAR. But once we reach there, the data which is at that house, that is basically stored in my MDR. And now my MDR and MAR goes back to the CPU, where it's being then the data is being brought in into the CIR and then it's being executed there. Now for all the questions which you have, So for all the questions, I'm going to recap it in this diagram. So what happens is that we have a program counter, okay? So this program counter stores the address of the next task. For instance, I might say that, okay, I'm currently waiting for a package to be picked up from Gulberg because I need to execute that. So whenever I, like, let's say I now want to go to the house which is at Gulberg, which from where I need to grab the data and execute it. So my program counter is going to store the address of the next task, which is basically executing the Gulberg project. So the address of the Gulberg project is in my PC. So once I need to execute it, the address is first and foremost going to be copied into MAR. MAR, because it's my taxi driver, is going to take me to that position in my hard drive. So it's going to take me to that position in my SSD, where what's going to happen is that we're going to have the address value, so like the binary value, like binary or like position number 123 or like 0110 1011 0011 and all that stuff, and every location will have some value next to it. So it's going to go to a specific location. Who is going to take us? The MAR is going to take us. So the MAR is going to take us, and then the data which is at that position, let's say we say that we had some food like khana, okay? So that khana is going to be taken from that house at that address, and then that khana will be, because it's the data, it's going to be stored in my MDR. So once that's being stored in my MDR, now my MAR is again going to take me back to my CPU, and inside my CPU I'm going to go to the CIR. So whatever data I just took out from the hard drive, I'm going to copy that data into my CIR, and I know what a CIR does. A CIR basically executes the stuff. So whatever my instruction was of, let's say, ordering the food, so now I have to eat the food, right? So let's say when I bring the data into CIR, my CIR is going to execute it maybe by I'm eating it, and boom, I'm done. So the moment this has been executed, till then we're going to have some other address or like the next task which needs to be executed. So the moment we get to working on this, I give a signal to my program counter that, okay buddy, bring up the next file. So to call a program counter to basically bring up the next file so that they can again follow this exact same order, what we do is we increment its value. By incrementing, I mean that program counter, like you would have seen going to doctors, right? And they're like, okay, this is patient number 1, patient number 2, patient number 3, and so on. So like for every task that is being coming up, so like originally there was 0 tasks, but the moment this becomes as 1, this is a signal that, okay, the last one, nothing has been, or for instance it was 10, but the moment this becomes 11, it's going to be a signal to the program counter that, okay bro, the 10th one has started to be executed, bring up the next file. So this bringing of the next file is what we in computer science call as repeating of the stuff, and this is being signaled using incrementing. So by incrementing by 1, which you would have seen in marking scheme, you're going to understand that when we say increment the program counter by 1, this basically means that whatever the value of program counter was, you increase that by 1 to signal the program counter that, okay bro, whatever the address of the next location you have, go and copy that into MAR so the whole process could be followed up. And that is how your whole computer basically grabs data, executes that data, and this entire process which I just said, that's known as the fetch execute cycle, which would be our next topic too, inshallah. So right now we have understood a lot of the components. So what happened was that back in 1940s there was this problem that the computers did not have any sort of physical memory. Okay, they had no physical memory at all, which meant that the biggest problem was that if I, let's say, wanted to play some game, I could either plug it in, the moment I take it off, it's going to stop working. So it could not work on its own, which was a very big problem for us. But then what happened was that there was a computer scientist with the name of von Neumann who came up and they introduced its architecture with the name of von Neumann architecture that basically brought up the stored program concept. So if ever in exam they ask you about a question that discuss the stored program concept, a question has been tested on this, don't be like, bro, this is some out of syllabus question, I don't know, I'm cooked. No, you are not cooked. Whenever they talk about stored program concept, they're referring to the von Neumann architecture, okay? And when we talk about the von Neumann architecture, we are basically discussing this whole model, where all the way your data from program counter goes to MAR, then the data comes into MDR, that data goes into CIR, if there is some mathematical calculation on that data, that goes into the accumulator, then basically your ALU deals with the accumulator, whereas your control unit deals with both the CIR and the control unit. And of course somebody asked this question and stated this previously, that sir, where does system clock behave? So system clock is something which operates under the control unit. So when I said that the control unit is executing what do you call it, it's creating those timing signals. So how does the control unit create those timing signals? That is something which it does through the system clock. But of course, to connect all these smaller registers, to connect all these components, we also need wires. So in the world of computer science, we don't just call them wires. We said that okay, we're going to specify the types of the wires. So like the one wire name is address bus, one is data bus, one is control bus, and now we're going to see what each of them do and what are their unique characteristics. Okay, so just understand that the first type of wire which we have in our syllabus, it's with the name of address bus. Address bus comes from the name of address, where it basically just carries the memory addresses. So like it's going to take me to memory location 1.00 or 100.101. So this address which my MAR carries, the route which it's going to follow, that is basically the route of the address bus. Okay, and one point here to note is that if a question comes up asking about the features of an address bus, just know that an address bus is unidirectional. By unidirectional, I mean that the address can only go in one direction, which means that if I'm, let's say, looking for an address, it's gonna go only in this direction. There isn't a possibility that some other component comes this way to find the address up here. So it's like a one-way route only. Okay, you cannot be like, okay, I want to find the address in the CPU. That's not possible. And one other point as to why basically it's unidirectional, because if it wasn't unidirectional, then you would have been like, okay, let me search in the CPU to find the address, which isn't something logical, right? So to prevent the addresses from being sent back to the CPU, what we do is we kept the address bus to be a unidirectional sort of bus, so that it only carries the data in one direction. One point here to note is that sometimes the question comes up upon improving the performance. So to improve the performance of something, you can increase the length or the width of a bus. By width of the bus, I mean that let's say this is a road. Okay, it's a road which can on max carry 2 cars. But this is a wider road which can now carry 5 cars at once. So now you tell me which of the two will be having less traffic. Okay, which one of the two will be having less traffic? This one, right? The 5 cars one. That's pretty much obvious. So similarly, when we increase the width of the bus, this basically increase the capacity of the addresses it can carry at once. Which means that at one point, if up here only 6 cars were passing through, we can clearly see up here 15 cars can pass through. Which means that the process of execution is now very fast, and thus my computer performance has also increased. So we have a question where the student is saying, sir, are von Neumann architecture and fetch decode execute cycle the same thing? So just know that fetch execute cycle is the process through which the data is executed, and the components which the fetch execute cycle uses, those components are arranged in a model which we call as the von Neumann architecture. So von Neumann architecture is the model which places those components in a specific order, and then the way the data goes through that order and is being executed, that is known as the fetch decode execute cycle. Okay. Secondly, the second bus in our syllabus is the data bus, which again is pretty much similar. It carries data, but this isn't unidirectional, it's bidirectional, which means that okay, data can go from the memory to CPU. Similarly, it can go from the CPU to memory, and likewise. Okay, and again the same point that the wider the bus, the more data it could carry at once. And the last one is basically the control bus, which basically carries the control signals. By control signals, I mean that okay, I went to a specific house, so I now need to read the data. So who is going to be that commanding force who is going to tell me that okay, read? Or who is going to be that commanding force who is going to tell me that okay, write the data in this memory location? So these signals which basically command me to read something, to write something, or maybe to even interrupt something, which you would have studied in chapter number 4, which stops something when something having a greater priority is being executed. That is something which my control bus does. And how does it do that? It basically does that by carrying control signals. Likewise, control bus also is bidirectional, it's not unidirectional, and the signals in this case is basically sent from the control unit to the other components. So your control units, remember I said that the control units is basically the CEO. So likewise, this CEO, we can also say exactly Gursim, that control bus is the CEO of my buses, because it's going to be that CEO is going to ensure that okay, you need to send the address in this much time. Why is it getting delayed? The data needs to come from this direction. Why is it being delayed? So this is basically going to carry control signal to ensure that everything else is being done in the right order. So if something is happening in the computer at some point, the perfection of everything is being carried out thanks to the signals transferred through the control bus. Perfect. So this is one other simple model of fetch, the von Neumann architecture. I would recommend memorizing this, but yeah, this is a simpler one. If you just want to have a look at it, it's the same one, but it's very smaller, and I would not recommend you to draw this at all. If ever in exam they ask you, you need to draw something similar to this. Moving on, right now we need to understand one more thing. We're going to discuss the course part, don't worry Minahir, okay? So how does the whole computer work? So your computer follows a model where you have some file. That file goes into the CPU. The CPU executes that part, and boom, this whole cycle is then repeated. But it's not like file, CPU, and executed. The formal computer science words for that is basically fetch, decode, and execute. Okay? Fetch, decode, and execute. So what does fetch mean? Fetch is that stage of a computer CPU where you get the data from the memory. Decode is that stage of the computer where you analyze the data and you understand what it requires and how I'm going to solve it. Whereas execute is that part where you basically solve the whole problem, you get some answer and you give that answer to the user as an output. Now in exam, please don't write words like person, he or she, I gave it to the person on the or the people watching the screen. Bro, you need to use computer science related terminologies, which means that you need to give your answer such as that you're going to give the user the output. So you need to make use of words like users, okay? And so the way your computer works is this whole model of fetch, execute, cycle. And ever in exam they ask you for this cycle, don't write FEC, write it in always full form, okay? So the way it starts working is, I have explained this in great detail, but again, your computer is going to check are there any instructions. If there are, definitely they are going to be stored in the program counter. Okay, it's going to be stored in the program counter. So your program counter is going to be containing the address of the memory location which has the next instruction. That is going to be then taken into MAR. The MAR is going to go to that point, it's going to grab the data into MDR. The MDR is then going to take the data to CIR, and then we are going to increment the program counter to indicate that, bro, you can get to the next work. And finally, once this has been executed, I'm going to see that, okay, is there anything else I need to do? If yes, I'm going to go and repeat the whole thing. But if no, I'll be like, okay, let me end up, and boom, there is nothing else. And that is how your computer executes everything. Now we need to look up onto how, if I want to improve the performance of my computer, I can do that. So the first way to increasing the or improving the performance of a computer is by increasing the width of the address and data bus. So if you increase the width of the address and the data bus, let's say if originally my address bus was only carrying 10 addresses, now it can carry 100 addresses. Now definitely that's going to improve my performance. So that's one point of improving my performance. Second one is by overclocking my computer. By overclocking, what do I mean by overclocking? To understand that, you need to understand that in a computer we have something known as the clock speed. Okay, so every processor has a clock speed, and clock speed basically refers to the number of fetch execute cycles your computer can execute every second. So if the clock speed is high, this means that it can execute more number of processes every second, right? So if I have to increase my performance, let's say my company's default performance rate was 3.5 gigahertz, which is the unit, but if I, let's say, increase it to something like 4.33 gigahertz, this basically means that I can now introduce much more functions in the same time slot. So this means that I can carry out more fetch execute cycles. And so if I can increase the speed somehow, this means that I can carry out more tasks, which eventually means that my performance has increased. And this concept where I have to increase the performance of my computer from the default performance value set by the company, that is known as overclocking, where you increase the power of a processor more than its default value. And how do you do that? That is something not in your syllabus, but just I taught my students that you need to go to the BIOS and then you're going to go to the system function setting and you can change it. Okay, and what this does is that when you do overclocking, this allows more instructions to be executed at once, but there are a few problems of it too. And the problems are that if you do this, your CPU can heat up, which can again lower the performance, and at the same time your overclocking has this one big issue, because everything is going to happen very, very fast, but your control unit and everything else are still set to the default value. They might not be able to get synchronized with it. Okay, they might not be able to get synchronized with it, which would mean that it could crash the computer, which is again a big problem for us. So if ever you want to overclock it, it can benefit, but again there is a big challenge in this too. So we have crossed 1,000 subscribers. Let's go. Congratulations, Code Catalyst family. That's such a great achievement. Let me see, did we cross? We did, I guess, right? How much for subscribers do we have? So let me see. It's not being showing up on my phone though, but let's see. 1K. Congratulations, everybody. That's so great to know. That's so great to know. So it is the average speed of the process 2.4. It depends on the processor. Okay, it's not necessarily going to be 2.4. It can vary. But yeah, these are two ways of doing it. And the third way to basically improving your performance is using cache memory. Now, what's cache memory? So we studied something with the name of RAM, right? But now what we did was the computer scientists were like, okay, bro, we have RAM, but what if we introduce something even more faster than RAM? So they created a small chunk of memory, a very small chunk of memory, and they gave it the name of cache memory. And they were like, okay, this part is even going to be more faster than what RAM is. So like way more faster than RAM. But it's going to be very less in size. So whatever important we have, we're going to store that in the cache memory, so that if I'm accessing something frequently, you would have seen, right, when you download Google browser for the first time and you open up a website, it takes longer, but the next time you open it up, it takes less time. Why does that happen? Why does that happen? Okay, so it happens because that stuff which you're trying to frequently access, that is being stored in the much faster RAM, what do we call it, storage part, which we know called as a cache memory. Because this cache memory is even faster to access from the CPU perspective, we say that if I can somehow increase the memory of the cache, which is very, very expensive, but if I do that, that can also improve my performance of the computer. And that is really, really great thing. And last thing is that you can make use of multiple cores. Now someone had a question, what are cores? So core basically is a combination of ALU, control unit, and register. So this one CPU which we studied, this one CPU could be called as one core. So a lot of our computers are like, let's say, dual core. By dual core, we mean that we basically have two cores installed in the same computer. So we had one CPU and then we have the other CPU. And the two CPUs are then basically interlinked with each other. Okay, so they are interlinked with each other. And now this CPU can do one task, this CPU can then do other tasks. Likewise, if it's quad core, it's going to have more tasks being executed at once. If it's like 8 octa core, it's going to have 8 processes executed at once. So when we use multiple cores, this means that we have multiple sort of ALU, multiple CU, multiple registers. And when we are connecting each other, this basically means that one CPU can do one task, the other CPU can do the other task, which would just mean that, okay, I can do more number of instructions per second, thus improving my performance of a computer. But there is one problem with it. If we have a lot of cores, let's say like 16 cores, okay, 16 cores. So remember, every core is going to be interconnected with each other, like core number 1, core number 2, core 3, core 4, all of them are basically interconnected with each other. So if we have a lot of cores, because when they get connect with each other and they also have to communicate with each other, the biggest problem is that the performance then degrades. Because definitely if I'm only talking to one friend, that's easy, but if I ask you to talk to all the 115 people who are taking the class right now live, it's going to be very challenging, right? And that too in DMs, one by one. So it's going to be very challenging. And when we do something like this, there's a chance that the performance may degrade. So at one point, yes, using multiple cores can improve the performance, but if you do multiple cores to a very large extent, there is also a possibility that your performance gets degraded. Okay? All right, so I'm gonna tell you how you can find the notes on my website. Okay, so go to the resources section on my website. Go to the resources section. Up there, you're gonna go to the notes section and click on that note drive link, and it's gonna take you to the note part. Okay. Finally, the last part of chapter number 3.1 is discussing the instruction set. So what's instruction set? Instruction set is again a list which your CPU has created, which has all the possible instructions my computer can do. So like definitely I cannot do everything on my computer, right? Like there are some predefined things which I can do on my computer. If there is something not defined, I cannot do it, right? So the list of everything which my computer can do, all the instructions which my computer can execute, that is known as an instruction set. And your instruction, which we talked about till this point, this instruction is basically made up of two parts. One is known as the opcode and the other is known as the operand. So opcode basically is that part of my instruction which tells the CPU what operation needs to be done, whereas operand is that part of my instruction which tells the CPU that on what data do I need to basically act, or on what data do I need to basically do this operation. For instance, if I have to give you an example, if I do this 8 multiplied by 2, the value 8 is basically my operand. Why? Because it tells the CPU that you need to basically execute this on this specific part. Whereas the operation, like let's say I had to multiply by 2, double it up, this operation which we have, that is something known as opcode. So opcode is the operation, whereas operand is the data on which it needs to be executed. Now one other point here to note is that our CPU has a limited number of operations, due to which you're always going to have limited number of opcodes. But that's how the whole thing works. You have a CPU, inside those you have components, those components follow the fetch execute cycle, and every instruction which your fetch execute cycle executes, it does that using the instruction set model. And that basically summarizes our chapter number 3.1 to a large extent. All right, that was really good. Okay, so right now we're gonna take just 5 minutes break. How long will the stream be? I don't know, maybe 12:40, 12:50. But yeah, we're gonna just take 5 minutes break, only 5 minutes break, not a longer break. But in these 5 minutes, you can just go drink water, maybe if you want to rest a bit. But yeah, you can just rest, and then we're gonna continue back from the embedded systems part. Okay, so can I do chapter number 6? That would be a bit challenging. However, we're gonna do a lot of questions of chapter 6, so we're gonna understand the concept there too. So don't worry. Okay, once you do those topical classes with me, you're inshallah gonna understand the concepts in great detail too. So we're gonna have a small break till 11:45, and then after that we're gonna get back to the course content. So you have a break till 11:45. Alright, assalamu alaikum everybody. Am I audible? Alright, let me have a look. You okay, perfect. So just give me a second, let me just say this one thing. How do I set this up? Okay, perfect. Let me put it up here. Alright, great. Let's get back to the course content then. So we're gonna be now starting the content all the way from embedded systems, right? So when we talk about embedded system is sort of a mini computer, okay? It's basically a combination of both the hardware and the software, which is basically designed to done a specific set of tasks. So like the normal computer which we have, like something like a laptop, the computer and all that stuff, all those things are basically hardware plus software, just like embedded system. But we know that a laptop can do multiple tasks. It can allow us to maybe take classes, it can allow us to play games, it can allow us to maybe watch YouTube or whatnot, right? So it could do multiple tasks. So remember that embedded system is basically that part of your computer systems where you combine hardware and software, but you do that to design something which can only do a single task. Okay, so I'm going to come to this input output debate inshallah just in like 5-10 minutes, so don't worry. Okay, so now for example, I took this example of a washing machine which has sensors which are my hardware, it has a software, and but if you see, we combine the hardware and software, but it only does one task, which is basically washing our clothes. So because it does only a single task of washing our clothes, we call that to be an embedded system. Likewise, we have basically multiple other examples which I have discussed later on, but the point here to understand is that you have three types of embedded system. The first one is known as a microcontroller. What is a microcontroller? A microcontroller is that type of embedded system where you have a CPU, you have RAM and ROM, and you have other peripheral devices. Now what does peripheral device mean? Peripheral devices are all that points from which you can allow your computer to be connected to something. So for instance, if this is my microphone, okay guys, if this is my microphone, this microphone, if you focus upon up here, you see this point where I can plug something inside it, right? This plugging in point is what I call as a peripheral device. Okay, so what my microcontroller does is that microcontroller basically joins in the CPU, a RAM ROM chip, and the peripheral devices all onto a single chip. So it's just a chip which has everything on it, but it is not like something which can work on its own. It's like, okay, I'm only providing you with a CPU, with a microcontroller, with a processor which you can then connect to your own stuff, and then based upon that you can create whatever you want to create. The second one is known as a microprocessor. A microprocessor has now a circuit where it has the CPU, but then apart from the CPU, it has no RAM, it has no ROM, it has no peripheral device, it has nothing inside it. So for instance, if I say this microcontroller is basically sort of an advanced version where I have added some things onto that plain microprocessor to make it a microcontroller. And if I, let's say, might want to go into even further step where I might want to say that, okay, no, I don't want it to be something where I have peripherals devices only for input or where I have to personally plug it. I want like a whole system. So the third type of embedded system is known as the systems on chip, where you have a fully microcontroller present on it, and then which basically means that it has a CPU, memory, input output port, secondary storage, and all that stuff. And then it's up to you how you might want to program it so that it meets your own requirement. Okay, so these are the three types of your embedded system. The first one is known as microcontroller, the second one is microprocessor, and the third one is systems on chips. Just to give you a quick example, microprocessor is the base variant. Okay, it's just the CPU. So if I say, I can say it's like a plain chicken. Okay, then if I say that microcontroller is like one additional way above, where you, like, let's say, do some processing, you add the RAM ROM and you add just a few components to it, and it comes out to be as a fried chicken. And let's say I want to make some Chinese dish like Manchurian. So like if I want to make a Manchurian or something of that nature, I have to then add those fried chicken into smaller chunks and like add those into the sauces, right? So if I have to basically add all that stuff later on, everything of that will be then done on systems on chip, which basically means that okay, I even take the microcontroller part and I add more components to it to make it like a fully operating computer, and that computer is then known as systems on chip. All right, so these are the three types of input out. These are the three types of embedded systems in your syllabus, and you should be well aware of them. So, how does the embedded system generally work? It always takes some sort of an input. The input could be analog, which means that where you need to change it, maybe using a dial, using a button, or it could be through digital one where you can basically have a signal, and then that input is going to go to the software and hardware part on the system where it's going to be processed. Of course, at the same time, there might be some interface from the user, so you're going to have user interface, and of course at the same time it's going to give you an output. A quick example would be discussing this part of, let's say, having a set top box, these PDCL smart TV devices. So what happens in them is that you have a front box, and that front box basically has the signals coming in from cable. Okay, and then your box, which this set-top box we have, it has RAM, it has SSD, it has this remote input point from where it takes in the signal, and based upon this, when the data comes inside it, the interface then basically tells us that okay, it's going to process all that stuff and it's going to give me an output in terms of HDMI, which is then connected to my TV, and on my TV I can see the output. Okay, so this is just an example of an embedded system which combines software and hardware, and by combining the two things it forms a device which only does one task, which is to basically maybe play TV or play videos, okay, play a recording. So it's only playing some sort of movie type of video, right? So such things are basically known as embedded devices. Now there are multiple other examples which I have discussed up here. You can review all of them if you have time from the notes, but for now the point important to understand is what are the benefits and what are the drawbacks of an embedded system. So the benefits are pretty much straightforward. They are like very small in size because it's only designed for a specific task, so you can easily fit it into whatever device you might want to add it to. Then of course, because we are going to do it for a specific task only, we say that it's also relatively lower cost to make. Then of course, because it's usually dedicated to one task only, I don't have to add complex stuff to ensure that it works for everything. Perhaps even a simple interface like a simple dial, a simple button, a simple menu can work. Okay, then because it has a smaller size and it does not do a lot of things, I say that it also consumes very less power. It can also be remotely controlled, and of course the best part is that it can be very fastly reactive to any input change, like the way we have TV. So I click on the remote button and it changes the TV channel, right? So I say that it is very fast too. And the best part is that because these are small and they are like produced at a very large level, like all these automatic washing machines, they are produced at such a large extent, such a large level, that I say that when we produce to such a mass level, we also have a great reliability coming alongside it. So these are like the benefits for embedded system, but at the same time there are also drawbacks. The drawbacks are that it's really difficult to upgrade. Like okay, you bought like a washing machine, now you cannot upgrade that washing machine, right? You need to either sell it up and you need to buy a newer one. So that's one drawback. Second one is that if let's say a problem comes into it, because it's something which does only a specific task, there aren't a lot of people who are technically expert to solve the problem. So troubleshooting these faults would also be a big challenge. Similarly, even though it may seem like that at some point the interface is similar, there could also be possibility, yeah, this is relevant to O level as well. The whole syllabus for O level and IGCSE, it's 100% same for CS. Okay, so the syllabus for IGCSE and O level is 100% same, don't worry. So everything I am trying to explain up here, you should know this. So likewise, you should know that okay, of course the interface may seem easier, but like if I'm just creating an automatic pressure cooker and then it has a lot of steps to set time, do a multiple tasks, then that could become a bit complex too. Okay, and then of course the best drawback, or like the best point which you can mention in exam, is that because this could be connected to internet, there is a great chance that it could be accessed by hackers, viruses and all other type of malware. And of course you also have difficulty in upgrading them and finding faults. And just because we cannot upgrade it, the biggest problem is that if I, let's say, now have a chance to buy something new, I'm just gonna throw it away because I cannot upgrade it, I cannot improve it. I'll be like, okay, I don't need it, let me just throw it. So this basically can increase the trend in throw away in the society, because anything which is being out of date, you're just throwing it up, and so that could be also a potential drawback. Now Included has sort of, still you should be aware this isn't basically embedded system ki wo, it's basically just for your own understanding that how do you differ between microcontroller, microprocessor and system on chips. It's better to have an idea. Okay, these are things which are going to help you understand the topic in more detail. Moving on, a good question was, sir, do we need to know all these examples? No, you do not need to know the examples. What you need to know is that how does your computer take some sort of input, okay? Then it basically taking that input, how does it basically process that up, how does it take some interface input from the user, and how does it gives us some output. So in exam they're going to give you a specific scenario. They would be like, okay, this is the scenario and now you explain how an embedded system might work. So tell them, okay, these are the inputs that can work, this is how the whole system is going to work, and this is how it's going to give you an output. We're going to do chapter number 3 topical questions in great detail inshallah. So in that you're going to see if we find something related to embedded system, we're going to do those two. When will the stream end? So around about 12:45 inshallah. So 45 minutes later. So these are just a few examples, you can look onto them. Now coming to the input devices part. So what are input devices? These are basically devices which allow us to send data to the computer. Okay, so any data which are basically going into the computer, it needs to go in terms of binary. So whenever I type something, the device basically converts my human language into the binary language, and the device which converts this my data into binary, that's basically my input device. Now the biggest confusion needs to be cleared up here, that you do not need to memorize the working of an input output device at all. Here is an official reply from Cambridge Assessment International Education Direct Examiner, who stated that to reassure you in respect of input and output devices for the previous syllabus, which was last examined in 2022, candidates were required to know how each device works. For example, they were required to know how does an input device scan a barcode and convert it into digital binary. Whereas for the new syllabus, you are only required to know what each device does, why it does it, like where we might require it, and when it might need to be used. So like the question can now at this point come up, like what's a touch screen? Where should we make use of a touch screen? Why does a touch screen perform well at this stage? So like you should know the pros and cons for each device. So you should know the pros and cons. You should know where to be used, and you should basically know what it is. So if you know these 3 points, you're good to go. Now if you look up on my notes, you're going to see that these notes have also covered up a bit of extra detail upon its understanding. That was just so that my students can understand what they are, but you're not required to know how it works and anything of that. You're only required to know what an input device is, why is it required, what are its benefits, what are its pros and cons, and where it might be used. And these are the only devices for which you need to know. So what's a barcode scanner? Again, a barcode scanner is basically an input device which basically scans any barcode code like this and converts it into basically binary value like 0, 1, 0, 0, 1, which can then be used by your computer. So it's basically what it does is it's something which is being used in these libraries, in these shopping markets, where whenever you purchase something, the company or the cashier, what they do is they grab this device, they scan it up, and boom, the item has been scanned, and then you move on, grab the next item, and at the end this basically allows you to basically create a final bill. So your barcode scanner is something which is being mainly used for checkout purposes. It could be used in libraries, it could be used in medical store, it could be used in superstores, and what it generally does is that it's best for the usage of database. So like every time I scan a barcode, I can set a software where like every time I click something, this means that okay, boom, I have understood that I have purchased one item, which means that in the database I can reduce its quantity by one. And when I'm going to create the software, I can set up that okay bro, whenever I have my Kokomo stock going less than 30, where I have less than 30 Kokomo stock left, you should automatically restock the limit. So you can then automatically go up and it's going to restock the entire stock again. So this is how you can basically make use of a barcode scanner. Just read this part and you would be really good to understand how, where could all these devices be used. So here are a few advantages of using barcodes for management and customers. So for the management, definitely if we have barcode, this means it's going to be easier for them to change the prices, because you just change it on the system and every time you scan it up, the newer price comes up, right? Similarly, everything could be digitalized. You don't need to manually change the stock item. You can automatically change everything. You can automatically, because everything is going to be checked on the computer, you're only going to be basically, what do we call it, be checking the data once and everything is going to be updated automatically. And the best part is that by having the data digitalized, we can automatically find out what things are there in demand, what are the stuff which customers are preferring to buy, what things are they not buying. So based upon that, we can look into the trends and make a decision onto what we should buy. And what are the benefits to the customers? So for the customers, it's pretty much straightforward. You're going to have faster checkouts. Having the chances of making an error in the billing is reduced. You can have a printed receipt with you. You can see how much of the money I have saved. You can have a better tracking of the data which has been sold and all that stuff. So that's how you can basically make use of barcode scanner. Are we required to memorize the working? Sir, what is the process by which the barcode is scanned? So the process is not related. You are not required to know how it scans it up. It converts the dark part into 1, the light part into 0. That is not in your syllabus. Only thing you should know is that there is going to be a barcode scanner, which is basically going to scan some code like this. And then once it scans it up, it's going to process that data and boom, I'm going to have the value in my computer. And you are not required to know the memorizing. So there isn't any working. This isn't working. This part which I am saying that it's going to scan, this isn't the working. By working, I mean that when I talk about working basically means that you basically scan it up, and what happens is when you scan it up, the infrared red laser goes onto this barcode, and then the red laser gets to the black point where it does not get reflected. Because it's not getting reflected, my computer gets a black line, and for every black line it's going to take the value of 1, and for every white line where we have nothing, when it throws light onto it, it's going to reflect the light. So every reflected light is going to be counted as a 0, and based upon that, it's going to convert the light and dark colors into zeros and ones. That is something we call as the working. So this working is not included, but you should generally know how it generally works. You should not be aware of the process of what it exactly does, but you should know that what it's generally being used for. So alright, so how many do you have? So you are only required to know the input output devices which are in our syllabus. These, only these, nothing else. Okay, moving on. The second one is known as the QR code. QR code stands for quick response code, which are basically codes like this, and they are basically a code. It's like similar to barcode, but this QR code is a symbol. It's specific art, you can say, which basically hold data inside small boxes. So all these stuff are basically boxes, but boxes having black color and some having white color, and at the end it basically creates something like this. But what you do is you open up your phone, you scan this up, and this stores data up to like 4296 characters. You don't need to memorize it, but yeah, you should know that this stores data. So what you do is that every time you scan the QR code, you store the data, and the data is then presented to the user. So these boxes which you see at the end, they don't have any specific benefit, but its logic is that it basically helps with the alignment. So it basically tells you tells it to the computer or tells it to the phone that when you are scanning a QR code, it tells it that, okay bro, this is the alignment which you need to follow. You need to scan this part. So your computer first looks for these boundaries, and then based upon that, it sees how I need to scan it. So where can a QR code be used? It could be used for the purpose of advertising them. It could basically give automatic access to a website. It could store boarding passes, and you can just need to open up phone camera. You can scan it from your phone, and it could detect and then convert the pattern into some sort of code, and then it could be a data, and that data could be then opened up in your browser. The benefits are pretty much straightforward. They can hold way more information than the normal barcodes which we have in our syllabus. There are going to be less errors. They are easier to read. It is easier to transmit QR codes than writing like a whole text message. It is also possible that if I want to encrypt a QR code, I can do that. But the disadvantages lie in the fact that there are more than one QR codes available, and that there is a great possibility that a QR code stands up and it says that, okay, free pizza. And then there is someone like me who comes up and like, oh, free pizza, let me grab some free pizza, and then they scan it, but it had some sort of malicious code installed within it. So like, let's say some hack, some virus, some malware, and this concept is known as attacking. Okay, so if something like that happens, then boom, you're cooked. So these are a few disadvantages. And then there is also one third type of QR code known as the frame QR code. What's a frame QR code? It's basically that type of QR code which allows you to also add advertisement logo. So maybe rather than this sign up here, I can add the Code Catalyst logo. So it could basically be something to hint that, okay, this is of Code Catalyst. So a QR code which has data plus advertisement. So it basically allows us with all these aspects. Okay. So name of your website, the website has been pinned. You can open it up. It's codecatalyst.versal.app. I'm going to change the URL though, but yeah. Perfect. Let's move on. So now we're going to talk about digital cameras. What are digital cameras? So digital cameras are basically those devices. Perhaps let me connect the charger to my laptop too. I guess the battery is running low. So just give me a minute. Let me connect the charger. So what are these digital cameras? So what the digital cameras are, they basically replace the old cameras which we had, and it now has a lot of newer features too, and generally they are used to take images or maybe store movies or films, and the task which it generally carries are pretty much straightforward. You can adjust the shutter speed, you can basically focus on the image, you might operate like the flash gun, which is like the flash which you see that spark whenever there is no light and it's totally dark, and then you see your face clearly. That is basically the flash gun. You can also of course at the same time zoom in, zoom out, you can adjust it. You can, if you have ever noticed, I'm not sure though, but sometimes when you use the flash, your eyes basically are red colors. So how does the camera remove that? That is also a task which your digital camera does. So now according to the syllabus, you should know what are the tasks it does. How are all these tasks being executed? That's not in syllabus, but you should know what are the tasks which it could do. Just one other point here to note is that all these tasks are separately dealt by one embedded system. So we have like one separate embedded system for all of these tasks, and we join in all those embedded systems together to basically complete the whole system. Okay. सर जब पानी की सिप लेते तो स्क्रीन फ्रीज हो जाए तो कुछ करा नहीं रहा तो स्क्रीन फ्रीज होगी ना. But yeah, moving on, the next input device is keyboard. We all know what's a keyboard. It's the most commonly input device used for data entry. You have either it connected using a USB cable, you have it either using virtual Bluetooth, or you have the touch screen keyboard, and it's relatively a slower method of data entry. Why? Because if I'm like currently speaking, if I was to type all this stuff, it would have taken way more time. So it's a slower method, but yeah, it is a method. And there's a great chance you make errors, but still it's one of the most easiest way and preferred way from everyone. But of course, one problem is that if someone is a programmer, they type a lot, it can result in their strain energy from their in their hands. And so for that, we have a specific type of keyboard. This is just one point you should know. It's not in the syllabus though, but it's known as the ergonomic keyboard. And this ergonomic keyboard basically prevents this RSI, which is the repetitive strain injury. And this repetitive strain injury is just because you type a lot. Okay, and you're basically writing in the wrong posture. So yeah, moving on, the next input device in our syllabus is the microphone one. What's a microphone? It basically converts sound waves into electrical signals. So we have sound waves coming up, it goes through this whole process. What's the process? You're not required to know, but it goes through this device, and then at the end we have electrical signals. So this working is not in the syllabus. Okay, where do we make use of microphones? So you use it in video calls, you use it in gaming online. When I used to play Fortnite back in 2022 2023, you can use it for recording, the way you guys can hear my volume at the same time. That's all thanks to the microphone, right? So what it does is it takes my voice from in the air, which I'm currently speaking, and it converts it into the binary for the computer to understand. And just know that this microphone is basically a faster method of data transfer. Okay, data transfer. Moving on, just know that the microphone, the general way of how it works is that it generates electric current, okay, which then it goes into the computer, and then that is converted into binary using a sound card. Now this is an extra point, but just something which you should be aware of, that when we speak, that speaking is converted into binary, and that binary is basically then used by my computer thanks to a sound card which we have in our computer. Moving on, we have something known as an optical mouse. So an optical mouse is an example of a pointing device. You have two types of mouse. One was the mechanical mouse, the other one was, if I wrote it okay, but not. But then we have the newer types of mouse which we have nowadays. The mechanical mouse was a bit different, whereas the newer one, which we call as the optical mouse, it's basically the one which has a LED beneath it, right? So your mechanical mouse had this small big circular item inside it, which need to get rotated in order to the mouse to work, right? So what we say is that mechanical mouse had moving parts. which made it like less reliable. So this optical mouse which we have nowadays, they don't have any moving parts, so they are more reliable. The dirt which we have in the surroundings, because everything is being done using LEDs and lasers, we say that the dirt has nothing to do with it, and it cannot get trapped in a mechanical component. And of course there is no need to have any special surfaces when you make use of optical mouse. And of course there are a bit of wide mouse advantages in our syllabus over a Bluetooth mouse, which is that wide mouse does not have to face any signal loss due to constant pathway. It is also cheaper to operate, and of course there are fewer environmental issues because you are no longer required to dispose the batteries which were not required. Okay, so analog to digital converter, is it the other way around? That is something we're going to study later on, but just know that when we talk about input devices, when it converts what I'm saying into some digital content, which is basically my binary, this is something which is going from ADC, which is analog to digital converter. Clear or not? Alright, let's move on. So likewise we have then two types of scanners. What are scanners? Scanners are basically things which can allow your files or models to basically be scanned and converted into a computer model. Okay, computeristic digital model. So you have 2D scanners and you have 3D scanners. The 2D scanners are basically used to convert hard copy documents like pages into electronic form. So your computers are basically equipped with a software known as OCR. OCR refers to optical character recognition, which basically converts any sort of scanned text from the document into a text format. So let's say I wrote an essay, I scanned it up, I brought it to my computer, and now I can edit it through a word processor software. So how does it convert that image into the word processor? It's done thanks to the OCR. And then an image scan will be then, of course, if I scan an image, that image will be then stored in the image format, which could be like a JPEG format, PNG format, or something along that grounds. Okay, whereas a 3D scanner is like, let's say I have this bottle of water with me. Okay, if I, let's say, want to scan this whole thing so that my computer knows this whole exact model, maybe I might want to slice it up, I might want to modify it, I might want to do something alongside it. So if I want to scan a 3D object, for that we have something known as a 3D scanner, and this 3D scanner scans the object basically and creates a three-dimensional image of it in all three directions, like X, Y, and Z. So like X, Y, and like the third dimension, which is Z. Okay, and then these scanned images will be then further processed in a software known as CAD, which stands for computer aided design, which allows you to produce any sort of other model. Maybe you might want to change something, you want to add something inside it. So that model, the software which is used to basically modify such models or these 3D models, that is something known as CAD. And where can you use these scanners? So your scanners could be used in places like airports, where like you would have seen, if anybody has been to an airport, you're going to see that on airports you have those boarding passes, you have your passports being scanned. So how do they scan it? So they basically put the passport onto that system, and boom, you have your whole data on the computer. So it's basically everything is being scanned using a scanner. So these 2D scanners are used at airports to look for your tickets, for your boarding passes. Then of course you would have seen that every time you want to go out of the country or every time you board on a plane, they take a picture of you. So that picture is taken for the purpose of comparing it with your passport photo to see whether it is you or it's not you. So it measures all these factors. It checks for the distance, it checks the width, and blah 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 stuff to ensure whether it is you or not. Whereas for 3D scanners, if I, let's say, have a solid object, it divides that solid object into smaller chunks, which we call as slice, and then I can basically look onto each slice separately. Maybe I might want to change it, or like we can use this in the medical field in the world of CT scan, where you basically create a 3D image of a solid object, and then you can use it for your own usage, right? Okay, so if I might want to look onto this part of the human body which I just CT scanned to see whether there is something wrong, so I can do that all thanks to the CT scan. Okay. Acha, brain rot bhi dalna hai. Oh, of course we can add brain rot, but it's basically I don't have a lot of time, so for that reason I'm rushing it up a bit. But inshallah from the next few classes we will be, don't worry. Okay, we're gonna add that. I don't know why am I drinking this much water, but yeah, of course I just had like a crazy kadai before coming up, so of course it has to be the kadai effect, of course. But yeah, let's move on. So now the next input device which we have in our syllabus, that's the touch screen. So what's a touch screen? A touch screen is basically an input device which allows you to input data onto the system, right? And we have three types of touchscreen. One is known as the capacitive, one is known as infrared, one is known as resistive. You don't need to know the working, but you need to know the differences between all of them. What are the benefits of each of them? Okay, you need to know the benefits for all of them. This is the most important part. Okay, there is no other input device which has more important pros and cons than these three. So what a capacitive touchscreen does is, it consists of a glass layer, a conductive layer, and a protective layer, and it operates using the charge in the electrostatic field. Okay, then we have two types of capacitive screen. One is known as the surface one, which basically can work with bare fingers or even with the stylus. What's the stylus? This pen which I'm using, right, to write on the graphic tablet. And then what happens is that it works in a way where you have sensors all across the corner, and then when you touch it, it decreases the capacitance. That's irrelevant. Okay, and the second one is known as a projective capacitive screen, which basically makes use of transparent conductive layer, and then it basically, when you touch it, it changes the electrostatic field, and using that it basically determines your exact location. Okay, but this can work on bare fingers, stylus, and gloves. Now the benefit of this in regards to the other two technology is that it has a better image clarity than resistive touchscreen. It is more durable, and the projective capacitive screen, they allow multi-touch too. Say, whereas disadvantages of this is that surface capacitive screen only work with bare fingers, whereas they are also sensitive to electromagnetic radiation, so you might not even want to touch it, but if there is a slight radiation coming up, it might be like the computer would be picking it up as if you are pressing on the screen. So these are a few disadvantages. The second one is known as the infrared one, which basically has a glass layer, but it makes use of infrared sensors, and based upon that, wherever you touch it, the sensors determine what point you exactly clicked on. And the benefit you get for infrared is that they have multi-touch, they have a good screen durability, and that even if your screen is scratched or cracked, it does not affect its performance. But the disadvantage is that if you throw water onto it or there's some moisture, it might not work. And of course, at the same time, it's like if there are infrared beams somehow disturbed, then it could result in accidental activation. And sometimes your infrared rays are also very much sensitive to light interference. So if you're working at a place where there is a lot of light, in that case, your system will be basically sensitive and it might not work. मैं इंशाल्लाह चैप्टर 2, चैप्टर 3, चैप्टर 4, चैप्टर 5, चैप्टर 6 एंड चैप्टर नंबर 1 के टॉपिकल्स कराऊंगा. डोंट वरी. ओके, you're gonna have live classes inshallah 10 onwards, 10 p.m. onwards, and you'll be good to go. Sir, are you taking notes? No, I'm not taking notes. Why will I be taking notes? This document is available on my website. Okay, so you can just go and access it from there. Then the last one is the resistive touchscreen, which is basically made up of two layers of electrical resistive material. So when you press upon it, the circuit gets completed, and then boom, you have the whole thing working on. You can read this description later on, but the advantages we get is that it's having good resistance to dust and water, and it could be used with bare fingers, stylus, and gloved hands. However, there are also a few disadvantages, such as that it has a lower touch sensitivity, it also does not support multi-touch, it has a poor visibility in strong sunlight, and it's vulnerable to a lot of scratches. Okay, so all these points are like really important, and it's something you need to memorize. Okay, so these are points when I say that you need to memorize this stuff, not the working. This is what we are talking about when we talk about memorizing points. When we discuss on the other end the output devices, it basically, these are the devices which takes the digital data into something which a human can understand. The first output device in our syllabus is an actuator. What's an actuator? So you would have seen something like a conveyor belt in those airports, right? So it all operates on a computer. You press a button on computer, it starts working. You press a button on computer to stop, and it stops working. So how do you convert a digital command into some sort of mechanical force? How do you do that? So this conversion from digital to mechanical is something which my actuator does. So an actuator is an output device that converts electrical energy, which is my digital data, into mechanical force. Okay, so it basically has a signal, and that signal basically controls the movement. The second output device in our syllabus is known as light projectors, which are basically used to output the stuff on my computer onto larger screens. So there are two types of, what do we call it, projectors. One is known as the DLP, which makes use of millions of micro mirrors on a small chip, which we call as DMD, that is the digital micro mirror device. You should know these small points, but this whole process is not required. You aren't required to know all this. But the way it works is that these chips, they turn on and off again and again to produce different colors, and based upon that, it creates a whole image in front of us. The second type of display is known as the liquid crystal display, which is known as the LCD. Okay, so it's basically the LCD, and LCD is like an older technology. Again, the working is not required, but what happens is that it's having a powerful white beam of light which passes through these mirrors, and then it passes into a prism where using the prism it generates multiple different colors, and then that colors, when they pass through a lens, they are displayed onto a screen in a bigger size. Okay, moving on, what are the advantages and disadvantages? So the advantages for DLP are that they have a higher contrast ratio, they are more reliable, they are quieter, they are smaller and lighter. They are also more suited to dusty and smoky environments. But of course there are a few disadvantages, that they tend to suffer from shadows, they do not have gray components, and the color definition is not as good as that of the LCD projectors. As for the LCDs projectors, you should know LCD projectors give a sharper image, they have better color saturation, they're even more efficient, but the contrast ratios are not that good. They also have a limited life, which means that they degrade very quickly, and because these LCD projectors are organic in nature, anything organic in nature will basically tend to degrade over time, which means that any screen which you have made up of LCD, they over time are going to become yellow. So now if ever in your homes you would have those older TVs, okay, older TVs, something like those square sort of TVs, those square TVs are something, if you open them up, they're going to give you a yellowish tint. Why do they give a yellowish tint? The yellowish tint is because they made use of LCD panels, and because the LCD panels are organic in nature, they degraded over time, and boom, now you have a degraded screen in front of you. Perfect. Moving on, the next output device is the printer. So we have two types of printers, inkjet and laserjet. Laserjet, that's wrong, it's the laser printer, okay, my bad. Okay, laser printers. So the inkjet printers are the one which basically produces ink droplets by making use of liquid ink. Okay, they could be produced using two technologies. One is known as the piezoelectric, in which you have a crystal at the back of the printer which is given an electric charge, and then that causes it to vibrate. You should know what piezoelectric and thermal bubble is. Okay, you should not know the process, but you should know these 2 points. And then this piezoelectric basically ejects the ink onto the paper. Whereas we have the thermal bubble, where what happens is that we have tiny resistors, they create heat, and then that vaporizes the ink. So later on the bubble expands and the ink is ejected, and then it basically creates a vacuum which allows it to basically dry up, and we have the ink on the screen. So you just, on the paper by the way, sorry. So you should just know generally what they are. Again, a question cannot come up on this directly, but still you should just have a small idea about them. Okay, so one point here to note is that if you want to send some data from the computer all the way to the file, the data is in terms of, let's say, word, but your computer cannot, the printer cannot understand word, it can understand binary. So converting from the word to the binary which the printer can understand, this is something my printer driver does. Okay, and then we also have something known as a printer buffer, which is basically a temporary memory which again operates similar to the program counter which we had. So any data which is in a queue, which is waiting for its turn for it to be printed, temporarily that data is stored in a printed buffer. And then we have the laser printers, which basically make use of dry powder ink. Okay, and then basically using the properties of static electricity, it produces images. We have 4 toner cartridges, which means that it's gonna basically print the colors in terms of these 4, and using these 4 they are basically going to print all the possible colors. Now where will they be used? So if you want to make use of inkjet, you're going to use it when you need better color printing and whenever you want to print a fewer amount of pages, whereas you need to use laser when you need to print a high quality printout, very fast printout, a lot of printout, and when you need a lot of printing content, or like a lot of, or a great volume of production. So in exam they're going to give you a question where they're going to say clearly, they're going to mention it up that okay, in this scenario which printer should be used. So you need to tell whether it's laser or inkjet, and you need to write these points to explain your logic. Okay, so hey sir, if we consume your notes regarding we relevant to the examiner rather than learning, yep 100% inshallah. So if you just look on to my notes, they are more than enough for the input output part. Okay, these are only the stuff which are there in the syllabus. Perhaps even my notes, they have a few extra stuff for your own explanation, but yeah, if you look onto this, these are more than good. By the way guys, for all those discussing the papers, ये आप बाद में कर लेना, अभी ये क्लास देख लो, फिर उसके बाद पूरी रात डिस्कशन करना, सही ग्रुप में ओपन कर दूंगा. Moving on, 3D printers. Now 3D printers are basically similarly printers which now generate solid objects. Okay, so those CAD models which I just shared, if I now want to print that into existence, I'm going to make use of a 3D printer. What a 3D printer does is that it's basically again made use on laser and inkjet technology. It makes use of materials like ceramic, paper, powdered resin, powdered metal, and then it generates an object using one way known as additive manufacturing and using the other way known as subtractive manufacturing. So additive manufacturing refers to that specific method in which the object is built layer by layer. So like it's going to drop a bit of material, then it's going to drop more material, and eventually an item would be formed. So like maybe something will be dropped up here, then up here, then up here, then up here, then up here, and I see that an object is being formed. The second one is known as subtractive manufacturing, where I'm going to provide it a lot of material at once, and it's going to basically break the material so that I can have my final object created, just like carving a specific statue. Okay, so in the horror there are so many details so your horror book is not fully according to the syllabus. The horror book has a lot of extra stuff. That's why I always recommend everybody to look onto the syllabus. I've even shared the official Cambridge examiners terms, I've shared the official letters, I've shared everything. If still your teachers are saying that you need to memorize the horror book, bro, tell them to just stay silent, please. They are not aware of anything. Okay, so you don't have to memorize anything in the harder education. The harder education book clearly mentions that we have included all this stuff just to complete the topic, just to ensure that the student understands how it's going to work. But we Pakistani teachers are like, okay, whatever is in the harder education book, you need to know that, otherwise you are cooked, because that's our only book which I need to use for the purpose of acing the exam. But that's not true. That's the reason why I am recommending every one of you, if you have completed your preparation, before every next paper you go to open the syllabus and read the syllabus once on your own to see if there is something which you know or something which you don't know. Okay, it's really important. Please don't listen to these teachers of yours. They don't know anything. I'm talking about this like really. I've been through the process. I've seen multiple teachers. They tell the students memorize it. They're like, okay, ratta lagao, ratta nahi lagana when there is something not in the syllabus. Why are you wasting your precious time? Where are you wasting your precious energy on this? I've been through this process. I'm not that teacher who did not do the OA level themselves. Okay, I personally appeared in the 2023 May-June examination when the syllabus was updated, and since that point I know that none of the questions till this point have included a question clearly asking the candidates to give the working of an input-output device. So please guys, करने की कोई ज़रूरत नहीं है, सही है? लो जी. But in syllabus nothing mentioned except for the names and ये भी mentioned है, you see. By the way, अगर नहीं पता कि क्या करना है, so I just shared this examiner's email, right? So what else do you need? If a Cambridge examiner told me, the person who's going to create the paper, if they told us that you need to memorize this, then why are you doing something else? So just refer to this email and you would be good to go. If you need to take screenshot ले लो and you'll be good to go. किधर गया? यार बहुत ही नीचे चला गया. But never mind, I cannot go back. But yeah, you can open up my notes and up there you can find that email and that explains what you need to do. Say, if you want to send this to your teachers, send it to your teachers. Okay, I'm just telling you, take the part of it, go and send this in your groups. And if any of your teachers say that, okay, this person does not know how to teach CS because we have been teaching for the last 20-25 years, give them my number. I'm going to ensure that they understand how to teach the right way. Okay, पता नहीं यार पाकिस्तानी टीचर्स ये गलत कर रहे हैं, बच्चों को गलत रास्ते पे कर रहे हैं. For that reason, I'm telling you guys, just open up the syllabus, whatever you're studying, compare it with the syllabus. If you don't understand, there is some ambiguity, reach out to us and we're going to explain it to you. Okay, so how can you access my notes? Go to my website. The website is pinned, and then you go to the resources section. In the resources section, go to the notes part, and you're going to go to the whole drive. You're going to find all my notes. So now back to the content. So there are two types of printers. One is known as the direct 3D printer, which uses inkjet technology and it builds the object layer by layer. The second one is known as the binded 3D printer, which is again similar to the 3D printing which had the direct 3D printing method. But what happens up here is that you first make a layer, then you glue it using a binder, and then you make another layer. So it's like, okay, make one layer, add glue, make another layer, add glue, make another layer, add glue, and eventually you have a final object being created. Okay. So yeah, moving on, what are the usages of 3D printing? These are few usages. You can use the 3D printer in covering the prosthetic limbs. You can use it for constructive research of facial reconstruction. You can use it to, let's say, manufacture parts of aerospace which you might want to have a bit lighter. You can use it in the fashion and art industry. You can use it to create stuff which are no longer available in the industry, such as like suspension parts for a vintage car and all that stuff. Okay, moving on, the next output device is LCD and LEDs. LEDs are basically light emitting diodes. They are made up of tiny light emitting diodes, and when you combine a lot of them, you're gonna have a screen carried up, and then by changing the current to all those diodes, you can basically vary the colors and the images that are being created. So just know one point, that in your homes, the screens which you have, they are not fully LEDs, they are basically LCD screens with LED backlighting. So LCDs are basically liquid crystal display screens. They are made up of tiny crystals, but for it to work, the tiny crystal needs to have some light. Now the problem is LCD cannot generate light on its own. We need to have a backlighting source. So what we do is that there are crystals like this, and we provided light. So this light generally is provided by a LED, but the screen which we have up here, there is LCD. But now, back then when newer LED screens were introduced, this was the model being used, but now we have like full LED screens too. So just know that before the usage of LEDs, we had something known as CCFL, which was the cold cathode fluorescent lamp. This cold cathode fluorescent lamp, or CCFL, they basically had tubes behind the LCD screen which were basically used as a backlighting source, and then this backlighting basically provided to have a good contrast and a brightness range. But then again, LEDs had a lot of advantages over the CCFL. This was a monitor which you made use of the CCFL, and the best benefits were that you would have seen sometimes if you open up those older square TVs, when you open it up, it does not directly have a clear image. It's like a bit dull, but then over time it gets clear to its maximum brightness. So LEDs, they have this benefit that they directly reach to the maximum brightness immediately, whereas your CCFL, they have to warm up. Okay, they have to warm up. Similarly, LEDs, they give a whiter light than in comparison to the CCFL, which has a yellowish tint. Then LEDs, they produce a brighter light in comparison to your CCFL. You can also say that your LEDs, they last more than your CCFL, and of course, because it is a newer model, it uses less power, which means that it also creates less heat and thus also uses less energy, so it's way more efficient for me. Right now in the industry, we have the organic LEDs, which are known as the OLEDs. They are the most latest ones. These OLEDs basically make use of organic materials to create semiconductors which have a great flexibility, and they do not need any sort of backlighting at all. Okay, they don't need any backlighting at all. What they do is they automatically generate lights on their own, but they have like an organic nature. So you basically have an organic material like the way we have up here. So these OLED screens are made up of organic materials, and the best part of having an organic material is that an organic material can be very thin, and they can be basically even curved. So this gives us a lot of flexibility. Okay, this gives us a lot of flexibility, and that is the reason why we have these curved monitors too. They follow this OLED technology, and we can make use of these OLED screens everywhere, like maybe in smart clothing, maybe making something like wrapping over my wrist, maybe some folding phones and all that stuff. And the advantages I get of using OLED over LEDs and LCD is that OLEDs have more flexible, thinner and lighter screens. They are having LEDs which are way more lighter. They have a brighter light. They do not require backlighting at all. Because they do not require backlighting, this means that they're more efficient, and of course, because it can be curved and it has this much big flexibility, the field of view is also very large, which makes them very ideal for advertisement and television. Sir, if they are made of organic materials, do they degrade over time? That's a really good question, by the way. And yes, of course, they do get degraded, but with every passing day, the thing is, technology is improving to an extent where they're trying to ensure that this degrading period is reduced as much as possible. So they're trying to make use of plastics which do not get degraded quickly. But yes, of course, this could be a problem that can come up, especially with the usage of organic materials. Oh, so we have Mars Munir 2.0. Wow. Crazy. So CS ना पढ़ो, बाकी जो करना है करो. Very good. Proud of you all. Result day पे ना, on the result day, do one thing. On the result day, create an account with the name of Mars Munir 2.0 and then text your parents that, oh, your son did not get that A star because your son, rather than focusing on the class, was literally chilling, creating fake IDs and ensuring that he does not study. Okay, अपने पेरेंट्स को ये मैसेज भेज देना. Just kidding, just kidding. Okay, easy scene, easy scene. Alright, let's move on. So, the next output device in our syllabus is known as the loudspeakers. So, these loudspeakers, these are basically output devices that can produce sound. The data is basically converted from the analog form into analog form from the digital form. So, it's basically the digital to analog converter logic. The way it works is you have the signal, it goes through an amplifier DAC, and then we have it being coming up through the speaker, and it's basically a current coming up from the computer. How does the current come up? The current comes up from the digital binary we have up here. This creates a current, and the current basically generates, and once it's amplified, it's basically going to create sound through this model. Again, not included at all, but yeah, it generally uses the properties of magnetism to convert it into sound. And congratulations, we are done with input-output devices. Finally, alhamdulillah. So DAC or ADC. So this basically makes use of DAC. Why? Because it's a speaker. Your speaker converts the digital sound which is in binary into analog form, which we have up here. Okay. Moving on. The next part of our syllabus is known as that of sensors. So these are basically input devices that read physical properties from our surrounding. They measure the data, and then based upon that, it's going to make decision. So how does a sensor work? So a sensor works in a way where it basically takes data from the surrounding. Okay, it's going to take data from the surrounding, then that data is going to be converted into digital format using something known as an ADC. So an analog to digital converter, or an ADC, is a hardware piece which converts any analog data, human data, anything which can change like sensor data, into something digital. Or in simple words, it's going to convert all of our hours data into zeros and ones. And then we have something known as DAC, which is digital to analog converter. Digital to analog converter, which basically converts those zeros and ones into something which we can understand. Okay. Sir, why the hell are you teaching working if it is not part of the syllabus? Buddy, I'm not teaching the working. If I was to teach the working, then you would have been cooked at this point. So yeah, by working, I basically mean that you are not required to know the logic behind this. By working, I mean that you are not required to know the logic of amplifier. But you are required to know that how does a speaker generally works, that it converts the digital format into a speaker by amplifying it by making use of a digital to analog converter. So you need to know this part, okay? But you shouldn't be aware of how this whole vibration happens in the cone, which basically ensures that the coil is vibrating, and when this is basically vibrating, the magnet is going to get magnetized, and then based upon that a current is going to be induced. That is what we talk and mean by saying that the working is not in syllabus. So you guys need to redefine this definition of your working. You do not understand what's working up here. So yeah, my teacher said we cannot use abbreviation. You can use abbreviations, but it's not recommended. Okay. Okay, moving on. So you have multiple sensors. We have the temperature sensor, which measures temperature. You have the examples below, you can view those. We have the moisture sensor, we have the humidity sensor, we have the light sensor, we have the pressure sensor, we have the sound sensors, and then we have the infrared sensors. We have the infrared passive sensors. One is the active one, which basically is the one which you generally see as to be like those invisible rays going on, where if someone is being detected, it's going to break the rays, and then based upon that, there is a big difference. So there's a big difference. So the syllabus says that you are not required to know the working. By working, let me explain it to you. By working, I mean that you aren't required to know how it fully executes the process step by step, but the syllabus clearly mentions that you should be aware of what that device does. For that, you should know that what it generally does. So you aren't required to know what each one by one step is. Like you aren't required to know what a speaker one by one does. Like it takes the sound, it converts it into current, then based upon that something is being induced, then there is electricity current flowing out, and then based upon that the volume is basically, or the sound is generated. But you should be aware that okay, it's going to make use of some magnetical properties to create sound. So आपको general पता ज़रूर होना चाहिए, okay? But those step by step working, that's not required. So then likewise, infrared active is the one where basically, Mariam, I did not see your question. Thank you so much, Mariam. That's so great of you. That's great of you. आप खुश? But yeah. Alright, so infrared active are the one where, let's say you have infrared sensor coming up and there is this beam where whenever someone comes up, the beam is broken up, and then basically based upon that it's going to make a decision. Whereas infrared passive is that sensor which basically measures the heat radiation from all the people, okay, from all the people, and then based upon those it's basically going to detect peoples and all that stuff. Alright, so guys, सबके कर लूँगा, easy scene है. Let me just cover it up. And then we have a gas sensor, we have a pH sensor. So I'm not explaining this because these are really easy, and even if you just read the description later on from the notes, you would be good to go. What's an accelerometer? It measures the acceleration. What's a magnetic field sensor? It measures any change in magnetic field. What's a proximity sensor? Proximity sensor is that sensor which detects if something is really close to you. So if I have like a phone with me, you would have seen sometimes you're talking on a WhatsApp call, a VM is being played, and then you bring the phone close to your what do you call it, ear, and it automatically converts this sensor. How does it do that? It's because we have a proximity sensor in our phone. Okay, likewise we have a flow sensor which measures the flow or rate of a moving gas or a liquid. Then we have a level sensor which tells us how much of a liquid is left in a specific container, and of course then that's it for us. So you can just memorize all of these sensors and you would be good to go. Okay, so how does your sensor generally works? So the way it works is that your sensor always sends the data to your microprocessor or a computer. The data which is then sent to your computer, that is then converted into digital format using an ADC. Then once your computer has that digital data, if let's say we have two types of systems, okay, we have two types of systems. The two types of system basically works in a way. One is known as monitoring system and the other is known as control system. So monitoring system is where, let's say, you might want to make use of the sensors just for the fact that if something goes outside the range, let's say I'm working in a factory where the moment the temperature exceeds 50 degree, I want to basically set an alarm. Okay, set an alarm. So anything where I'm just monitoring it up and I'm not doing something if something goes wrong, but I'm warning the person that okay, something is going wrong, that is the monitoring system. The other is known as control system, where, like, let's say if I say that the temperature goes greater than 50, so I should automatically turn on the ACs to ensure that everything is being set up so that it's normalized, so that I'm giving the computer the whole power of doing stuff on its own. That's known as the control system. So the way it works is that once your data comes from the sensor, let's say it's getting the temperature data, it's converted into digital format. So now my computers know that okay, the temperature is, let's say, 65 Celsius. So now every time the computer receives the data, it's going to check it against the stored values. By stored values, I mean that while I was creating the program, while I was trying to create the program, when I was writing the code, I will tell it, right, that when the temperature is greater than 50, you need to turn on AC. So if it is greater than the stored value, which was of 50, in that case, if the data is outside the acceptable range, the microprocessor is going to send signals to control the valves, the motors, to turn on ACs, to turn on other components, and blah 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 stuff. And based upon that, it's basically going to execute something. If it does it that way, that's my control system. But if, let's say, it basically detects that something is outside the range, and let's say it's only displaying a warning or like an alarm is being activated, but it's not trying to stop it, that is a system known as monitoring system. And if, let's say, the data is within the range, let's say the temperature was something like a 35, in that case that 35 temperature is going to be what do we call it, okay, yeah, so if the temperature is something like 35, that 35 is going to be like okay, it's within the acceptable range. Because it's within the acceptable range, you would be like okay, let's go, we are perfectly, let's just move on. Okay, so you aren't going to do something. So that's how your sensors generally work on, and that summarizes the whole of chapter number 3.2. So it's 12:45 a.m. and sort of I'm cooked at this point. We had like a 2 hours class, but we are just left with a small part of data storage. It's not that long though, but it's going to still take like 30-35 more minutes. So okay, so should we do it or should we stop it at this point? What do you guys say? Yep, the diagram shows that exactly. So we do have a bit of the part left where we just need to discuss the memory, but what we can do is we can discuss the memory part inshallah in some other class. Maybe in tomorrow's class we can quickly start off with the memory, or perhaps the memory part is not that challenging. The biggest hurdle was with the RAM and ROM. So sorry, with the input output devices. Um, so stop, that was arts physics paper. Yeah, I know. Yeah. So you guys had a physics paper today too. So I feel like let's just stop it for today. We can continue from this tomorrow. We can continue the same part. We can quickly go through the memory part, which is the main challenge for all of you. And tomorrow's class will be inshallah at 10 p.m. or maybe I'm gonna announce it soon. But yeah, we're gonna do those. And yeah, that's it for today. I hope the class was somewhat helpful and that you guys learned a bit about how input output devices are going to work. So let me know if you understood it or not. If there are any questions, anything you might want to ask, so मैं जवाब दे देता हूँ. सर एक सवाल था, प्रॉक्सी सर्वर हाइड करता है पब्लिक आईपी एड्रेस एंड हैव कैशिंग देन फायरवॉल. हुज़ैफा, आपके क्वेश्चन की मुझे समझ नहीं आई. Sir, please do Feb March papers. Feb March papers might not be possible because they're not officially released. Because a paper is not officially released, we aren't allowed to solve it. Okay. No problem at all, guys. I'm glad it helped you all understand the whole chapter number 3. Even though I was like very cooked today, but yeah, फिर भी कर लिया. And only one question on how car braking system works. So that car braking system example ये आप कहाँ से refer करें? Are you talking in terms of the sensors or are you talking about something else? So आप किस context में बता रहे हो so that I can explain उस लिहाज से. So there was a past paper question in the differences. Actually, we're going to do this question inshallah when we are discussing the past paper topic for chapter number 4 and chapter number 5. तो उसमें ये easily discuss हो जाएगा सारे आपके proxy server, because I feel like आपको थोड़ा सा proxy server and firewall के differences में मसला है. So inshallah we're going to do a question on that and फिर आपको clear हो जाएगा. अच्छा, sensor का, so basically that works in a way where let's say we set up that if let's say the speed or like the level of all 4 tires, if they exceed if they're like less than a specific limit, which means that I now need to basically put a brake. So what the computer does is we set it up that let's say there is a standard level of 20. Okay, so the moment the level gets below 20, I need to stop. Okay, so your sensors are within the tires, they try to get the data, and the moment the data of the tires exceed the limit or gets below the limit of let's say 20, my computer now knows that okay bro, I need to put the brakes onto action. So the moment it gets out of this range, it's basically going to be just putting those brakes, and at that point my computer is going to ensure that the brakes have been perfectly applied. Okay, so that's how generally it works. P2 हम करेंगे inshallah. We're going to do paper number 2s from 14th, 15th, 16th and the 17th. So 4 days we're going to do inshallah paper number 2s. We're going to do back to back 15 markers. Yeah, I know they are available, but they are not officially available. They are like those papers which have been released from the exam centers. They aren't officially released by Cambridge. So if you are solving it, it's not like legally available. Okay. सर पिछले साल का ग्रेड थ्रेशोल्ड में 125 अबव था. इट्स बेसिकली पिछले साल 15 मार्कर में सबको 15/15 दे दिया था. देयर वाज अ प्रॉब्लम विद द 15 मार्कर. द प्रॉब्लम वाज कि उन्होंने क्वेश्चन के अंदर बोल दिया था देयर आर गोना बी 3 प्रोसीजर्स, 3 पैरामीटर्स फॉर अ फंक्शन. सो योर सिलेबस स्टेट्स दैट देयर आर ओनली गोइंग टू बी 2 पैरामीटर्स. सो बिकॉज ऑफ दैट दे कैंसल्ड द एंटायर क्वेश्चन एंड दे गेव एवरी सिंगल किड 15/15. सो लाइक इमेजिन इवन द जीरो scoring marks student also got a 15/15. So for that reason the threshold went on to 124. But don't worry, itna masla nahi hoga. Thank you so much, Uzaifa. What is the difference between CPU and CPU? So CPU is like a whole big thing and control unit is one part of CPU. So CPU is like the whole company, and within the company CU is basically the boss or the CEO, which deals with all the other components to ensure everything is being done the right way. So basically CU comes under CPU. Alright guys, then it's 12:50. Okay, that's it for today. We're gonna have a live stream tomorrow too inshallah at the same time. Maybe if I have to change it a bit, but yeah, that's it for today. Take care everybody and bye bye. Sir, can you solve them on a meeting and not upload them on a YouTube channel? No. If it's not officially allowed, so I won't do it, okay? Sir, आप कौन सी uni में या jobs? I am a freshman at LUMS. So I'm a first year student at LUMS, majoring in computer science and hopefully inshallah minor in quantum computing. Warisha, I did not get your question. You can reach out to me in my DMs. मैं बता दूंगा भाई. सही है? Okay, take care everybody. That's it for today. Allah Hafiz. See you guys inshallah tomorrow.